And hello all, it's Mr. Callen here to help you with today's assignment. First, going to put up some answers from the homework review so you can pause and then go on to the next page when you're ready. Some more answers. Make sure you're ready to turn this assignment in on Monday. And speaking of Monday and the week's schedule, a focus today on the worksheet and the video. And then next couple days, Friday is going to be day 1 of the test. Monday will be day 2. Goal is to explore different representations of the same linear relationship, whether that's a table of values, whether that's a graph, whether it's an equation, whether it's an equation in slope-intercept form, all different ways, or whether it's words for that matter, all different ways of representing the same relationship. And remember what we have, table of values could lead to a graph where we have an x-intercept on the x-axis, we have a y-intercept on the y-axis. Standard form equation have both the x and the y's on the same side with a constant term on the other side. Meanwhile, slope-intercept equation will give us that y-intercept value, and the slope would lead to more points that we could use to graph this relationship. So keep that vocabulary in mind as we continue. Go ahead, please pause, read through the verbal description, come on back when you're ready. So I'm going to go ahead and mark my text up, folks, what you hopefully already did. We got cones for $2 each. Furthermore, we have $8 for a specialty sundae. And then yada, 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 spent total $40. Now at this point you can go any different direction, but I'm going to invite you to pause your video, see if you can write the equation in standard form, and come on back when you are ready. Now what I'm seeing here, we got cones, we got $2, $2, $2. We don't know how many $2, so I'm going to write 2 times x. No. I notice here both in the graph as well as in the table that they give us variables of c and s. So $2 times c number of cones will be the first part of the equation. Following that, I notice we had $8 for specialty sundaes. And again, I would use 8y, but they give us s for a variable, so I'm going to use a little bitty s. In the end, a total of, looks like a total of $40. So I'm going to go ahead and put that 40 right in here. There's our equation. Now, folks, why don't you go ahead, just as we learned how to solve for y to get y equals mx plus b, let's go ahead and solve for s. I would invite you to go ahead and pause your video, go ahead and see if you can solve for s. Come on back when you're ready. So first step for me, if I know all my s's are together and on one side, where should I put some work here? This is going to be a little sloppy for a minute. Let's do my work down off to the side. So we have 2 s's, an additional 8 cone. Nope. Focus, Mr. Callen. We have 2 per cone, 8 per specialty sundae, $40 in total. All my sundaes are together. So let me make this a little bigger. I'm going to go ahead and I'm going to subtract 2c from both sides. That leaves me with 8 per sundae, and you may write the c term or the 40 term in front. I personally like writing the variable term in front, positive 40 below that. But I don't want to know what 8 times s is, I just want to know what s is. So let's go ahead and divide everything by 8. I like to put it underneath each term. That will leave me with 40 divided by 8, or a 5 sundae beginning. And then negative 2 to 8 does not divide, but it does reduce quite nicely. And again, for those of you that would have preferred to put the 40 front, then that will divide 5, subtract 1/4 per cone. Shoot, you could even have put that in decimal form for those of you that are decimal lovers out there. So I'm going to go ahead, I'm going to write that equation up above, negative 1 to 4 for each c cone purchased, starting with 5. Now, I wanted to start with those equations, folks, but at this point you get to decide where you head, graph, table, or continue on with the analysis. I think I'm going to go to the table next. So if you'd like, pause your video, see if you can fill out some of those. Meanwhile, Let's continue. So I notice for this they give us a couple different numbers, a couple different quantities. Starting off with 0 cones, find the number of Sundays. 4 cones, find the number of Sundays. S Sundays, find the number of cones. What I'm going to do is I'm going to write this equation a couple times. You may use either of the equations. We've talked about that. They are, after all, equivalent equations, so their solutions will be the same. I'm going to go ahead and use the original, 2 per cone, 8 per Sunday, $40 total. And then I take a look and I ask myself, well, what is given to us here? Well, it looks to me like 4 is the cone's value, so where it says C, I'm going to write a 4. Meanwhile, 3 is the Sunday's value, so in my other equation, I'm going to go ahead and substitute 3 in for Sundays. Now you can see how these equations are similar. Both of them we substituted in a number. Both of them we will attempt to solve for a missing variable. How are they different? Well, obviously we put the numbers in the different place. 2 times 4 is 8. And over here, 8 times 3 is 24. Now we go ahead and we use our solving skills. I'm going to go silent and just watch, listen. Well, don't listen if I go silent, huh? Look how these equations are similar. Look how they're different. So in this case, when there are 4 cones purchased, there were 4 Sundays purchased. Weird that the 4 and 4 is the same. Meanwhile, when there are 3 Sundays purchased, that led to 8 cones being purchased. Again, if I use my little disappearing ink here, look at this first step. After we multiplied, we eliminated the constant term. We got rid of the 24, we got rid of the 8. How do we eliminate multiply? Divide. How do we eliminate multiply? Divide. Both of these leading to the missing piece that we were trying to solve for. Now, pause for a second. Another number they give us is 0. Is that going to be more like the red on the left or the green on the right? Perhaps you can see, because 0 is the number of cones, we'll substitute 0 in for C. But of course 0 times anything is 0, right? Therefore, that leaves us with nothing to subtract. We didn't spend any money on cones. We still have that $40. And of course, when we divide 40 by 8, we'll get 5. So when 0 cones are purchased, we have enough money for 5 Sundays. Now, I'm going to encourage you at this point to go ahead, come up with your own number, and I would highly recommend pick a number of cones and pick a number of Sundays so you can practice both types of equations. Press pause, do those, come on back when you're ready. I myself would continue the pattern, so 0, 4 to 8 to 12. When I substitute in 12, I would find that I only have enough for 2 Sundays left over. If I then just went, you know what, I would go all the way to 0 because I find that interesting, I find that helpful. So if I were to substitute in 0 Sundays, that means I didn't spend any money on Sundays. So I don't have to take away any money. I still have $40 left over. And when I would divide 40 by 2, that would leave me with, you guessed it, 20 cones purchased. I find those helpful, ladies and gents. You'll see why in a minute. So now we can go into either the graph or the analysis, but with a table of values, I'm going to predict that many of you want to go straight into the graph. So let's go ahead and plot some points at this time. Remembering that no matter what points, what relationship we talk about, they all should come up to the $40 spent. So I'm going to start with 0.5, then go to 4.4, 0.5 right here. Then I'm going to find 4 cones, so go 4 to the right, and then 4 sundaes, 4 up. After that, we had 8 cones and 3 sundaes, 12 cones and 2, 16 cones if you would want to fill in the blank because the next one is going to be 20. Now, I'm not going to say you have to draw a line, but if you did, you would see a nice straight line through those points. All right, folks, so that means our graph is complete. We already were given the words, the verbal description. We got a table of values, so let's go ahead and continue on with the analysis. Find each intercept. Go ahead and pause for a second. See if you can continue with the rest of these. Come on back when you're ready. Intercepts, ladies and gents. If we had nothing but sundaes, where would that intercept have started? It would have started at 0.5. What if we had nothing but cones and no sundaes? Well, that of course would be 20 cones and 0 sundaes. Notice what they have in common. They both have a 0 quantity. But for the x-intercept, we know the x, we know the y is nothing. For the y-intercept, the x is 0, and we can find the y. Choose one point, go ahead and pause, come up with your own point, and tell me what it means. Come on back when you're ready. I myself, I'll just go ahead and choose this 8.3. And will I have space to write my sentence? I guess I could type it in, huh? Could be kind of small. So if I chose 8.3, what does this 8.3 mean? The team could purchase 8 blank and 3 blank while spending $40 in total. Now, obviously your job would be to fill in the blank, right? In this case, it would be 8 cones, noticing that 8 is the x-coordinate, noticing that 8 is here in the cones table, noticing that 8 would be here on the horizontal axis, and then naturally that would leave us room for 3 sundaes. All right, is there a minimum value of sundaes? Is there a maximum? This is not something we've talked about in 9th grade, but you have explored it in 8th grade. So you could go to your either table or graph, but I notice there's no way to go past 5 sundaes. If I kept going, I'd get into the negatives for cones. You can't have negatives for cones. So the highest possible, the maximum would be 5 sundaes. As for a minimum, if I went the other direction, I can't go past 0. Like, you can't have negative sundaes, so the minimum would be negative. I just wanted to review those terms of maximum and minimum, which we will be talking more about as the days go on. So folks, there you have it. I hope that you've learned a little about how to describe relationships in numerous different ways. We got words, we got graph, we got table, and we got an equation in a couple different ways. Standard form equation, where both the variables are together and on one side, constant term on the other. Maybe you can often think of it as the total. And then we have a slope-intercept equation. Oh, and by the way, go ahead and take a look at that slope and y-intercept. Can we see those? Where do we see those on the graph? So look where that 5 is, and look where that y-intercept is, right on the y-axis. Look where the slope is, and then look what happens. It goes down 1 sundae for every 4 cones purchased, 1 sundae for every 4 cones purchased, 1 sundae for, and you see that's why we call it a constant rate of change. So that's the power of slope-intercept equations. That's it for me now. Do well, folks. Remember that you are studying up because we got day 1 of the test coming up tomorrow on Friday, day 2 on Monday. Take care, do well, let's grow. See ya.